We have some light bulbs on the table here. And these two light bulbs make light in a very different way. These bulbs are incandescent. They glow because they're hot. And as we saw in the last chapter, objects that are hot give off electromagnetic waves. And these are hot enough that they give off a significant amount of energy in the visible light spectrum. These bulbs are LEDs, and they only give off light when the voltage through them is larger than some value. And that means the light that these two things produce is very different in a fundamental way. We're going to take a high-speed camera view of these two different lights and see how they differ. The incandescent bulbs glow brightly all the time. The glow is continuous, but the LEDs flicker. And it turns out that the LED bulbs only light when the current goes in one direction. And the electricity we have in this country, as you'll learn in chapter 26, is AC, or alternating current. The current switches directions 60 times every second. And so the LEDs turn on and off 60 times every second. They only light when the current is going in one direction. But why do we use alternating currents? Why do we use alternating current? In a word, transformers. And now we're going to take a look at transformers. And transformers are the second big part which we consider in chapter 26. This light bulb requires 12 volts to operate, but the electricity that comes out of the wall is 120 volts. How do we take 120 volts and turn it into 12 volts? The answer is with the transformer. And so the first stage in running this light bulb is to turn the 120 volts into a 12 volts. That's the job of a transformer. That's what this device is right here. And I'm sure you have many power packs like this that run electronic devices in your house. And each one of them starts by changing a high voltage to a lower voltage. And it uses a transformer to do this. Now, if you open up a power pack like that and look and see what's inside, there's something like this. And the transformer is a core of iron, and on it are wrapped two coils of wire. This one's the primary, and this one's the secondary. Lots of turns of wire, not as many turns of wire. Now let's take a look at this transformer. And this is a transformer that's intended for educational purposes. You can take it apart, and it's designed to work that way. This coil of wire is called the primary, and it's connected to a power supply. This coil of wire is called the secondary, and it's connected to a light bulb. And the light bulb in the chapter is something we'll call a load. Okay? Now, current comes out of the power supply into the primary coil. That magnetizes this iron core that's inside the transformer. And I can tell it's magnetized because if I try to pull it apart, I get a bit of a buzzing. And I can tell it wants to go back together. It's magnetized. This magnetic field induces a current in the secondary coil, and it's that induced current that drives the light bulb, or the load. I have a question for you. The current that comes in to the primary is AC. It must be AC, because what happens is this. There's a current inside this coil. It creates a magnetic field inside this core, and the magnetic field of this core is what induces a current in the secondary coil. There's no physical connection between these coils and the iron. It's not conducting electricity directly. The connection is entirely magnetic. And given that, why is it important that the electricity that comes in be AC? Use what you know about induction to answer this question. And you know that AC is going in one direction and then the other. So the magnetic field goes in one direction around this core and then the other. And so the magnetic field inside this secondary coil is changing. And that changing field induces a current. And so it's the changing field in the secondary that makes the current that runs the light bulb. And so the electricity runs the primary. The energy is carried to the secondary via the magnetic field inside this iron core. And I can tell that because if I take off the top so that I don't get as much magnetic field in the secondary, watch what happens to the brightness of the light bulb. And it noticeably dims. As a matter of fact, I can't even tell that it's lit. But the other thing transformers buy for us is this. You can use them to change voltage. And in the book, we're going to look at rules for how you'll set up a transformer to change a voltage. But let's do that right now. This transformer is set up with 200 turns on the primary, 400 turns on the secondary. Okay? Now I'm going to take this coil, which has 200 turns on it, and I'm going to swap it for one that has 400 turns on it. So I'm going to increase the turns, 200 to 400. I'm going to swap it so that the primary is now a 400 turn coil and the secondary is a 400 turn coil. And when I do this, here's a question for you. How will the brightness of the light bulb change from the first case with 200 turns to the second case with 400 turns on the primary? We'll give you some choices. Now this is what you might not have been sure of because we haven't talked about transformers in detail yet. But let's try it and see what happens. When I have 400 turns on the primary and 400 turns on the secondary, here's how bright the light bulb is. Not bright enough for me to tell that it's lit. And so there's a lower voltage on the secondary. 400 turns to 400 turns. I have a ratio of 1 to 1 on the turns. And when I do that, the voltage on the output is the same as the voltage on the input. And the voltage isn't high enough to light the light bulb. But if I switch the 400 turns for 200 turns, now I have a transformer that goes from 200 to 400, 1 to 2. The number of turns is higher on the secondary. And when I have a higher number of turns in the secondary, as you'll see in the chapter, that means that I have a higher voltage on the secondary. This is a so-called step-up transformer. And step the voltage up high enough that we can see that the light bulb is lit. But by changing the number of turns on the primary and the secondary, I can change the voltage that I get on the output, and I can turn one voltage into another voltage. And it's that ability to be able to transform voltages that is so useful, that is ultimately why we use AC electricity in this country.